Okay. So good morning, everyone. Welcome to another session of Data in Talk, the sessions for data, free data sessions that I'm doing. And today what I'm going to do is we'll continue with our journey on the data journey that we're going forward with a very essential topic, which is more on data storage and operations, right? Now, this topic, if you see, primarily will cover a lot of these different aspects across the different types of storage mediums, the different types of goals and principles that organizations take into account as part of their data storage strategy. Now, this specifically doesn't mention anything with respect to which storage technology that use or like a tool vendor specifically, but what it does is it basically mentions what are the goals and principles that you need to take in consideration, what are different types of concepts that are associated when it comes to data storage operations teams. They might be coming across different types of terminologies. What is the entire data lifecycle management, where DBAs, administrators have to take care into, what are different types of environments that go in, and what are different types of database administrators that exist, so these types of things. Then also, what are the different types of data architecture types that exist, like centralized, federated, distributed. So we'll go into each of these things and understand the differences between these different types of databases as well. We'll also see the blockchain database, we'll see virtualizations, cloud platforms, aspects across. Then we'll also see the different types of data processing, database processing types. What are the different types of properties that are associated with databases. So some of you might have heard about these properties like ACID properties, base properties. It speaks about that. Then we also have certain kind of theorems like the CAP theorem by Eric Rivers and all different types of data storage mediums. And over the years, the data storage, the mediums have evolved over the years. So what are different types of other SQL, NoSQL types of databases? What are different types of database environments that exist or, that can exist in an organization? Now, obviously, every organization is not the same, right? So you'll see some of these organizations might have all of them, some might be have few of them. It also depends on certain other priorities and decisions that the organization takes in. We'll see these different types of databases across them. Then what are different types of naming standards that exist? What are different types of implementation, guidelines, right? So naming standards, I'll speak about an ISO standard like ISO 11179, which speaks about, what are the semantics on metadata standardization and naming of, guidelines. Then implementation guidelines with respect to risk assessments, readiness assessments, we'll speak on that. From an organizational cultural change perspective or change management perspective, what are some of the things that needs to go ahead and do? And then what are some of the essential metrics? So like for example, when it comes to the entire metrics for calculations and evolving, what are some of the metrics that could be leveraged or could be useful for its performance maintenance or tracking, auditing, right? So these are some of the things that the chapter covers across. Again, as I was mentioning, if you feel that this chapter will go into more technicalities of explaining you how do you write DDL statements or DML statements and all. So this doesn't go into that, and not specifically on each of the technology, but at a data storage operations perspective, from an operations, from what are the different types of people, what are different types of, key terminologies and the key concepts that are required for a person to understand each of this is what this chapter speaks about. Okay. Now, if you see from CDMP's perspective, or what Dharma defines as, the entire data storage and operations is more of a kind of a journey. So it also it has these different types of phases. Like it includes the design phase, the implementation phase, the support that has been required. For example, from the entire storage of the data, right? Now, if you remember, from the earlier chapters, which I was speaking about the entire data lifecycle management, right? From right the point where the data is being collected, the data is being analyzed, the data is being processed, the data needs to be stored. So data storage, this entire space, even though it looks like a single block, there are multiple aspects that are associated. There are multiple key activities associated. In fact, each of these, right from collections and everything, each of this is in like a, activity in itself. So if you see, that's the reason it becomes essential to understand, and there's a specific, separate chapter that has been dedicated on this, that is on data storage and operations. Now, data storage and operations primarily will include two sub-activities. One is the database support that is required, right from, what is the support that is required for all the activities that are associated for your entire data life cycle. That is the first component. That is, you can see. And right from your initial implementation to the database environment that you are getting, right from collecting the data, backing up the data, purging the data, different types of activities, you will see that happens across that. So that is where your database support teams are required. At the same time, monitoring and performance tuning, sometimes the database is very slow and you see people reaching out and can we fine tune it? Can we do performance tuning and look at the explain plan of the database and try to optimize it? So these kind of things all will come under your database support. Then you also have the database technology support, right? So this technology support will take care about defining your technical requirements, that is required so that the technical architecture, the database architecture that is required, right from installing and administering the technology, what are the controls that you're going to put in, what are the kind of issue managements, how you're going to take it, right? So the one critical role that ties up each of a lot of these activities, your database administrators. You will see database administrators play a very key role in both these data storage operations perspective. Now, this is one of the more established, most widely adopted kind of a role you'll see within across organizations. And as we go further, I will also explain you what are the different types of different varieties or different subtypes of database administrators that could there, right? So in very simple terms, if you see the definition of data storage and operation includes your design, implementation, and the support that is required for the storage for storing the data so that we can start maximizing the value of it. Now, what are the different types of goals and the business drivers? If you can see, the three main goals that are primarily associated with data storage and operations as defined by Dama is firstly, it is to manage the availability of the data, right? So the data should be available throughout your entire life cycle. Even availability is part of one of the key properties for any kind of a database, that the data should be always available at a point in time. Then integrity of the data, the I part of it, the integrity of the data. At the same time, the performance, that the data should be able to be processed within the with specified time, and you should be able to retrieve the data without any kind of an issues, right? So these kind of things you will see associated. And then you will also see the different types of activity, the business drivers, which also includes a certain kind of principles that are associated, right? So goals and principles primarily tells you that what are the kind of principles that you can say or what you can, define, as part of it. Now, there are certain kind of these business drivers or business goals and principles that are associated. So on one side, you can see the business drivers, which will primarily that, that organization should be able to depend, like ultimately the storage of the data is important because a lot of the organizations heavily depend on this data for their operations, right? So, and it is very much critical for their working, for their operations, right? So business continuity is one of the key primary driver. If you say what is the key primary driver for business driver, so you can say business continuity. That the business should continue to work, it should not be having. And that's the reason because of this business continuity as one of the primary driver that drives the entire data storage operations as a key area. You will see a lot of these archiving, purging, deleting the data, performance tuning. All of these activities is primarily to achieve this business driver that is of business continuity. So this kind of thing. And then what are the types of goals and principles? So there are different types of goals and principles that I was mentioning. So one is the availability and ensuring the integrity, right? So these are the goals. And corresponding to this, there are certain kind of guiding principles, right? The first and foremost thing, one as part of the guiding principles is the automation piece. Like for example, can we start identifying and act on some of the automation opportunities, like the database development process, or the developing tools, the processes that are associated? Can we automate a lot of them, right? Can we try to reduce a lot of errors? Can we, reduce a lot of rework that is associated? Can we, reduce the time from development perspective and productionizing and using perspective? Then can the database administrators also work in a more agile way, so that whatever the requirement, newer requirements are coming in, it's not taking a lot of time for implementing, right? So a lot of time you'll see that data storage is not an independent as part of the Dharma wheel. Also, you see that it is one of the key components. So it will have to work hand in hand with your data modeling, area which we covered last week, and then we have the data architecture. So these are some of the key components that along with it has to. Then the second thing is reuse, so can we start building and promoting and developing the use of reusable data objects, right? So like, for example, a lot of times you will see a lot of these objects can be reused, data objects can be reused. We don't want it to be very tightly coupled to my database schemas, so this kind of thing will help me to reuse. Like, for example, what are some of the things that I want to reuse? Like, for example, certain functions. Can we change the inputs at a point in time and reuse that object? Or let's say, for example, triggers. Can we have some stored procedures created, which is more dynamic? Can I start reusing them? Right. So all these kind of things you will start seeing, where database developers, database administrators try to see that can we, rather than using hard coding or, having the same, something which is very static, can we make it reusable and taking the reusability in mind? What is the end goal that we want to object with want to achieve with respect to reuses? The database as quick as possible. Can we try to make it as painless as possible as well? Then try to understand and adopt some of the best practices, right? So some of these, this is very much important, right? So the database administrator, a lot of times organizations appoint database administrators who do not have a very good, understanding, conceptual clarity, things. And, or sometimes you'll see that a database administrator has been designated a person who is not even having a background, in database or, technology and all. Maybe that person is having some only basic understanding from a different stream, has no technology understanding, but they have been designated as DBAs. So that is not, because what happens is a lot of these DBAs who work, they have a good understanding of the different types of database standards, what are the best practices out there. So that kind of things helps them in understanding what should be taken in, what should not be taken in. Then the other thing is, can we start connecting the standards with the different types of requirements? Like, for example, can we define certain kind of service level agreements, the SLAs that we can have? So like that will help us to say that, okay, let's say if we have to define the quality, if we have to define integrity, we have defined completeness, what is the recommended? What is the threshold that we should define? So these kind of things will help me to understand, okay, from a standard perspective, I should only be able to use data if it is meeting this kind of a certain threshold, right? So the SLAs should primarily reflect what is the kind of what is the kind of a threshold or what is the kind of a minimum requirement that I should have as part of my overall standard requirements, right? So you'll see that some of them will try to align with some of the global standards or some of the industry standards like an ISO, like from quality perspective, they can align with an ISO 8000 or a data quality, some of the other data quality maturity frameworks, they can go. So these kind of alignment with the standards, or let's say I was mentioning about naming standards in the upcoming slides, we'll see. So an ISO 11179 can help them to align with them. So that kind of thing. So you know that, okay, you're not missing on any of these and you're aligned with the best practices as well. Then also setting the roles and responsibilities and the expectations for the DBAs is very much important, right? So as I mentioned, this entire chapter, you will see DBA's role playing a very important role, right? So understanding what is the kind of, right from the process from onboarding the DBA, what is the roles, what is the responsibilities, that should be very much very clearly mentioned. What is the kind of an expectations that the team will have. So, a lot of times the role of a DBA gets kind of overlined with the developer, a database, like the DBA starts getting assigned task which normally a database developer should be doing. So that kind of an expectation, mismatch should not be there. What is the kind of an expectation and what is the kind of the roles and responsibilities of the database administrator should also be very much clear. Now, what I'm going to do is I'm going to take some kind of essential concepts which I want to just spend some time so that you will get some clarity about these things. Because as I was mentioning, there would be so many different types of keywords that you will keep on hearing across them, right? So what I'm going to do is before coming to the different types of roles here, I will take a minute and we'll take some time and we'll try to go through some of the different types of terminologies that you have, right? So some of this you might already have heard about earlier, and some of you already have that understanding, but just to ensure that everyone is on the same page. So first thing is database, right? So if you see what is database, database is nothing but storage, collection of stored data, as you can say. So it could be structured, it could be unstructured, that is different. But database in very simple term is one of the storage medium where you would be able to store different types of data. Now within the database, you have something called as an instance, right? Instance of a database. Now what is an instance of a database? So you'll see a specific an execution of the database software, to a certain specific area of the storage medium. You have within the database, you have a database instance. So there you can see that, like for example, any organizations can have multiple instances, that will be executing concurrently, right? So these instances are primarily independent from each other. So multiple database instances could be existing as well, with a separate purpose. And then you also have something called a schema within the databases, right? So now what is a schema? So within a database, within the database or the instance, you can have a subset of a kind of you can divide the entire database into multiple schemas, right? So the reason why we have schemas is so that you can organize these objects into more manageable parts. Like, so for example, if you have understood or if you have heard about like the different, data warehouse projects, like you have a staging area, you have a landing area, you have a pre-landing area, you have a code, warehouse area, you have a data mart area. So if you want to keep all of it into a database, same database, what you can want to do is you want to separate them into separate schemas. Similarly, like if you have heard about Medallion architectures, you can have the bronze, silver, and gold schema. So these are nothing but different schemas that we want to have it across the same database. Or you want to have it within the same schema also, you can have it, but segregating into schema is like what happens is when you have the schema separated, one thing that you can do is you can have a separate owner, you can have the ownership controls defined, you can manage these schemas, you can isolate these objects. Sometimes you want in the staging area, you can see that you are just bringing all the data in the raw format, right? So you have, but in the data warehouse, you can have the controls with respect to the curations and all. So sensitive data identifications or read-only views, creations and all would be much easier. So schemas you can consider is primarily within a database, you have these different schemas getting created. Now you also have something called as a nodes, right? Now nodes are nothing but within the the computer or the machine that is basically hosting or processing the data as part of the data distributed database. That is primarily nothing but your node that you create. Then you also have something called as the abstraction, the database abstractions. Now, abstraction as the name suggests itself, right? So, for example, we don't, how do you basically define these entire database properties? So like when we want to connect to this different database, what is the kind of the calls that we want to make, right? So you have these different types of connectivities that could be created in the form of APIs, like you have the ODBC connections, you have the JDBC connections and all. So these kind of things is part of a database abstraction where you get some of the important advantages like of portability and the properties, some things that the properties could be managed well. Sometimes you want to apply key managements, you want to define abstractions and all. So those kind of things is very much possible. Now, one of the other things as part of the entire things is the role of the DBAs that I was mentioning, right? So the role of the DBA is most adopted and most important aspect as part of the entire data storage and operations. So they will perform most of the administrator related works. And these database administrators, the DBAs, they work along with the other people. Like, they cannot work single-handedly. So they work with your data stewards, they work with your data architects. So based on data architects, they based with your network administrators, data analyst, the securities analyst, and all different types of people who require data, who primarily have issues with respect to performance, who wants guidance and who wants to, enforce retention, recovery, and those kind of things. So these are the different types of people you will see that they would be working, right? And these DBAs, you can see they have been further segregated into these different subcategories or sub DBA types. So some of the DBAs might work on production environment. Some of them will be on application, are called as application DBAs. Some are also procedural DBAs and some of the development DBAs, right? And along with that, some of the organizations you can also see will have some of my network system administrators or the NSAs, network storage administrators, who primarily will support this data storage system. So each these different people you will normally see as part of them. Now let's understand what are the roles of each of them. Like for example, if you see your production DBA, what are some of the roles? What are some of my responsibilities of my production DBAs? So the whole, as the name suggests, of production DBAs, they primarily work mostly with your production databases, right? So they right from performance, reliability of the production databases, performance tuning, monitoring, error reporting, all these different types of activities. And there are different solutions that help in them as part of their administrative activities also nowadays that help them. Similarly, implementing backup recovery mechanisms, recovery and in case if there is the data has been lost, and also these people are primarily well equipped in these kind of activities also. Similarly, as part of your clustering, so for example, in case there, just to ensure that the failover is not, mechanisms for failovers and all, or continual data availability is ensured. So these kind of things are the activities that you will start seeing, which production DBAs will be doing. Then you also see that some of the other kind of database maintenance activities, like for example, archiving the data, or creating the what are the things that could be fine tuned, what are the queries that are taking a lot of time, so those kind of things, right? So monitoring the database performance, workloads, data volumes, ensuring the database availability is there, recovery, detecting and reporting any kind of an errors, so these kind of things you will see that the production DBAs would be normally doing. Then you also have the second type of DBAs, which are nothing but are also your application DBAs, right? So these application DBAs are normally responsible for one or more of these databases for the different types of environments, like the database development, test, QA environment, production environments. So these are very specific to the different applications, specific applications that you will be having. So they primarily, if you see, normally, some of the organizations have called them as application DBA. Some of them they call it as application custodians, right? So different ways primarily, but what they do is they are primarily one of the integral members of the application support team, and that application requires a specific database, and also they have very specific understanding of which database is required by that application, a specific application as part of the overall application architecture. So here you can see that these application DBAs sometimes will have to, since it is across the different environments and production DBAs, they will have to work with the production DBAs. Sometimes the application DBAs cannot have direct access to the production databases and all. So they have to liaise with your production databases to get all the things executed, so whatever the things is required, they have to work along with your production database DBAs. Then you also have the procedural and development DBAs. So procedural and development DBAs primarily review and administer what are the procedural database objects that are there in your databases, right? So they have a good technical understanding, like of procedures, of triggers, of functions, or the user-defined functions, or the UDFs that we call it. So normally this have certain kind of procedural logic, right, from planning, implementing, testing, sharing aspects. So you have the procedural DBAs who will be working on that. And then you have the DBAs in the specific, some of the specific environments, like applications are good for specific to application, but you also have certain database administrators who work only in the development environment. So you have the development DBAs. They primarily, support right from your database design perspective, creating or managing the user databases in the development environments, sandbox environments. Sometimes even the test you have, just like production development, you have something like a tester DBA also separately. Also, you sometimes you see. Then you also have the network storage administrators. So normally, these database administrators are concerned with the database side of things, but sometimes it also, as you see, the databases are not isolated. They cannot be separated out as part of the technology architecture. So they require to be connected to a network. So that network setup, what network requirements, what is the kind of network connectivity and all is primarily taken care by the network storage administrators. So they are concerned mostly with your hardware, software that are supporting the data storage. So like, for example, if I want to give you a very simple understanding, if you want to have like, say, for example, if you want to configure an Azure SQL database. So see, there are certain properties which from a database administrator perspective, what is the auto archiving, auto scaling, performance tuning, those things. And then you have a certain tab which will ask you what the IP details, public connectivity, private connectivity, what is the IP whitelisting and all. So that all those things is taken care by the network storage administrators. So on one side, you see one is more on the data side, how the data needs to be stored, the data needs to be backup, what is the frequency, those kind of things will be the role of the left-hand side. And the other side is the connectivity. And so normally you'll see that sometimes you are, even after you set up that as your SQL database also, sometimes the connectivity doesn't happen because the IP is not whitelisted, or while trying to connect, you start getting network connectivity issues. So those things are normally being resolved by your network storage administrators. Now, the next interesting thing to understand is what are the different types of database architectures that exist. So typically, if you see any of the databases could be classified into two main categories. One is the centralized or the distributed kind of databases. So in the left-hand side, you can see the centralized kind of a database where you see that there is a single database. Whereas in a distributed kind of a thing, you will have multiple database on multiple systems on the same system, but they primarily these work in a more of a distributed kind of a system. And what primarily within that also you have two main categories. You have the federated category and the non-federated kind of an architecture, right? So this depends on what kind of the autonomy that we have on the systems. So the federated would be working in a more autonomous kind of a fashion, and you have the non-federated, which is working more in a non-autonomous kind of a fashion. So what is the meaning of these? No, so centralized is very much easy to understand. So like all the data is there in my single place. All the users will try to come into a single place for the data. So centralization earlier, is more of a traditional kind of an approach where the data centralization was being there. But as you know, as the number of users starts getting increased, as the number of requests starts getting increased, so you see that there are certain kind of challenges, there are risk performance issues. So everything is dependent on the centralized place. And sometimes if the centralized system goes down, then there are no other alternatives. So gives you a complete storage, stoppage to your work. So these kind of challenges used to happen. And now the reason distributed databases are getting a lot of popularity, because as you see, the data is being, what you can say is distributed across the different types of nodes. And what another benefit of these kind of things is there are low cost commodity hardware servers that are being used. So scaling out becomes much easier. So each of these, there are different servers that could be there, and they have their own computation storage capabilities also. Then you can also achieve high availability. Replication of the data could be there. So even if one of the server is not responding, the data is being replicated across the other servers. So because of which data availability is very highly, possible. Then at the same time, scaling sometimes is possible, failover replications and all these kind of things you will start hearing where, I am trying to make my entire kind of database architecture more distributed rather than having it. So here you can see that one of the other things across my distributed databases is the federated kind of databases, right? So like, for example, if you have heard about the word about map reduce, right? So we have the mapping and the reducing as two different components as part of the map reduce kind of an architecture. So the data request, if you see, is being divided into multiple small fragments of the work, and each of them could be executed or re-executed in any of the nodes that is possible. So that is primarily as the data is located across my different types of nodes. The bandwidth across my cluster is could be improved. The data node failures or failovers could be managed, or you can see that the entire architecture tries to become more resilient. Right? So the federated kind of a database, as you can see, all of them primarily the tasks have been separated out, and they are primarily there is a kind of an autonomous kind of an you know architecture that we are able to do. And this is primarily more useful. Like, for example, if when you want to achieve data virtualization, when you want to divide Concord, there are multiple data requests that is coming in, right? So that kind of an architecture will be useful. And the federated kind of an architecture also could be of two types. You have a tightly coupled kind of an architecture or loosely coupled architecture. Now, loosely coupled and tightly coupled primarily work on what is the way the architecture looks like. So if you see the tight and these kind of tightly coupled, loosely couples have also taken as part of the overall architecture, if you see, goes into some of your monolithic and microservice-based architecture as an extension. So you can see the similar kind of a concepts. So in a tightly coupled kind of an architecture on the left-hand side, as you can see, there are different types of component systems. They use some of these independent processes. They would be publishing, constructing the integrated federated schemas, and then all the same schema can apply to all the parts of my federation. So there is no data replication that is happening because of the tightly coupling between the systems. Whereas in a loosely coupled systems, you will see that it is loosely coupled, the component databases will have their own federated schema. So normally what will happen, the user can try to typically access some of the other component database systems. You can have multi-database language. You can have levels of location transparency. You can have the federated schema identified, so these kind of benefits you will start seeing as part of the other things. Now, there are an example of a federated kind of a database you can consider is like your blockchain kind of a database, right? So normally blockchain kind of databases, as you understand, they use the entire contract management as one of the things. And, there are multiple blocks that have been created, right? So normally these kind of databases are very popular. You'll see as part of your, you have these ledgers that are being getting used as part of the blockchain databases. So in financial institutions and all, they are very, very useful where you want to do contract management or exchange of information happening between the different parties. So they have individual records and blocks that are part of it, and each of these transactions will have a record. What this database does is it basically creates a kind of a chain of these time-bound groups of transactions or the blocks. And these primarily has information from the previous block. So once that information from my previous block is identified, what it does is it passes that information to my next block and the data flows through. It also uses something called as a hash algorithm, right? So because of hash algorithm, what is coming in is we try to use this information. We store this information in the form of blocks, and this information is passed on to my next block. And once this block has been created, the hash algorithm, the hash primarily The block hash that is being associated with that block will not change, but what will happen is, any transactions that is any changes that is happening to my transactions or the blocks, which will have try to get matched along with the corresponding hash that is associated. Then virtualization, data virtualization is also one of the very important aspects. You have something called as cloud computing, right? So where what you're doing is trying to segregate these different types and try to use these different types of services, right? So as part of, you can see that the concept of virtualization initially started and cloud computing was one of some of the thing that took this and to a different level because the service oriented architecture, the utilities and all the different types of services that were available on the cloud, implementing on the cloud was possible. So same thing on the database perspective also. You see these were the different types of key components that started coming as part of the virtualization aspects. Now, primarily, if you see, there are different types of methods for implementing the database on the cloud. So like you can have it on the virtual machine, right? So at a virtual machine instance, you can have, and then you can run a database on these virtual machines. You can also have a database as a service, which is your DaaS kind of a model where you have in the cloud platforms, these database as a service. You don't need to have a or launch a virtual machine instance, but directly as a database as a service, you can start using install, you don't have to install and maintain the databases. You do the configurations as I was mentioning for Azure SQL and all. And then you also have the managed data hosting on the cloud where the database is not being offered as a service. But what it does is the cloud provider will host the database and it will manage its application correspondingly based on the owner's request, the user's request. Now, these database administrators will primarily have to understand a lot of these virtualization concepts, right? So they work with your network and system administrators. They basically do a lot of the standardization, consolidations aspects across and on the data backup recovery, data isolation, what is the data residency, these kind of things starts coming up, plays a very important role. And that's the reason you see that they will also liaise with the security teams. They also have to liaise with your privacy teams there with some of the things with respect to data residency and some of the regulations perspective. They need to understand some of these regulatory aspects as well. So they work with the data architects and all also as well. So you can see that what are different types of approaches. You can see the standardization, consolidation, server virtualizations, you have automation and the security as the four key pillars. That is what the virtualization or database administrators that will be looking into. Now, I was speaking about the different types of properties. So I will spend some time to understand these different types of properties. Now, normally, if you see, there are two basic types of database processing. One is you have the ACID and the base properties. So, and then you also have certain kind of theorem that basically speaks about the distributed system, so which kind of a uh, type of database processing could be used. Right now, ACID was primarily coined back in the 1980s, when databases as a concept, database as a enabler started getting a lot of prominence, and started getting a lot of relevancy. So here, ACID is basically consisting of four main properties. You have atomicity, consistency, isolation, and durability. So atomicity is primarily the operations that you're doing in a database should be identified at its atomic level, at its most granular level, right? And all the operations that you are looking into should be getting performed. So like for example, if one of this part of the transaction is failing, like there would be multiple read and write and transact kind of transactions that would be there as part of the entire operation. So if one of these transaction is failing, then the entire transaction is failing. Then consistency is that the operations that you're doing, the transaction that you're doing, should have a consistent kind of a behavior. It should not have, then when you've executed that statement, at one point in time, it is giving one result, and the other point in time, it is giving another kind of a result. So those kind of things should not happen. So it should have a consistent behavior. Isolation is that each of these transactions should be isolated, right? So you can have a serializable, those kind of things. You can be able to like read, write, and all could be isolated from each other, should be able to be isolated. Then durability speaks about that, let's say, for example, in case if there is any kind of a failure or any kind of a, things that is happening, it should not happen that all the data that is being stored in the database should be vanished. So it should be durable enough. It should be primarily if the transaction has been committed, then the after that the data should be saved in. It should not that it be lost. And then you also have the other side of spectrum, which is your base properties. So in base, what it mentions is it is basically available, soft state, and eventually consistent is one of the properties. So as part of the overall, the other side of diametric opposite of the asset properties, you have the base properties. So what it says is the system cannot at any point in time achieve all the asset properties. So what it says is the system should guarantee certain kind of availability when the data is, should be there. But base properties is normally associated with respect to, in case if there is any kind of data loss or failures and all. So what it says is the database should be basically available. The transaction should be available at point in time in a soft state, as in like in a constant state. There should be response that should be given, that will be given. But at each and every point and each and every transaction, I cannot guarantee at consistency, but at a point in time, if even if the system at an overall level is consistent, then that is still fine, So for each and every transaction, consistency is not required, but the system or the overall database should be in a consistent state. So that is more important. So base types of databases started getting a lot of required because the essence of big data environments where large number of data was coming in and all. I cannot essentially define consistency for each and everything, but if I know that large number of transactions are getting processed in parallel and all, but I can see that at a point in time at the end, if the system is in a consistent state, then that is I'm still fine with that kind of a requirement. Right? So those kind of things you will see. And then you have the CAP theorem, which was coined by Eric Brewer somewhere in 2000. So this theorem was again coined for the distributed kind of a system. So normally what the theorem says that the distributed system cannot normally comply with all the asset properties at a point in time, right? So the larger the system becomes, the compliance to all the asset properties starts getting less. So if you see consistency, availability, and partition tolerance, these are three main properties that I'm looking into. And these are some things you will see is also being associated with your NoSQL databases. Like for example, if you see some of your database like Cassandra's and all, right? So there you might see that only two of the properties would be supported, or your MongoDB, two of the properties could be supported. So all the three properties cannot be available at a point in time. The consistency, we know availability is where the database should be available and should be able to respond to all of these requests, right? And partition tolerances that the system should be able to continue to work even if there is any kind of a system failure that has happened, so it should not lose all these kind of, state. So these kind of properties, you will start seeing, which primarily will, tell you what kind of properties are associated at what point in time. So just to give some examples about the CAP theorem, which are the databases that primarily is sufficing what type of property. So if you see, like for example, if you have my availability, right? So some the basic properties as well as, so you have the consistency and availability. So CA, so normally your relational databases that will suffice. Then you have the availability, Cartesian tolerance, you have Couch database, Cassandra, DynamoDB, React that support availability and partition tolerance. And then you also have MongoDB, HBase, and Redis. They basically supports your consistency, partition tolerance as kind of things. Next, you also have the data storage medium. So data storage media is primarily the media in which so there are different types of data mediums in which the data could be useful as for your data storage mediums. So this primarily speaks about that, right? So in that you have different categories, right? So the most commonly used ones includes your disk and storage area networks. You have the SAN, which you call. Then you also have the in-memory data storage. You have the columnar databases, you have the columnar compression solutions, which are there. Then you also have the virtual storage area networks, your vSAN that you have been called. Then you have the cloud-based storage solutions. You have the radio frequency identifications or the RFIDs that are there. You have the digital wallets which are present. You have the data centers. You have the private, public, and the hybrid cloud storage mediums which are present. So you have the flash memories that you can see over here. So what are these disk and storage area networks that are there? So normally, if you want to store the data persistently, so disk storage is very popular. And as you know, most of you have used the disk storage, right? So this storage has the disk arrays, right? So you have these collected into different storage area networks or the SANs. And data movement on the SAN might not require a kind of a network identification because you can just move it, right? So based on the usage patterns, based on the data which is less used and all on slower access devices, you can basically use and keep them. Now, memory computations are largely where useful, where you don't want to keep the data form permanent, but you want to keep into volatile memory, you know. So one of the better benefit of the in-memory computations that you have seen for the database is the faster response time. So as part of the keeping the data on the disk and then getting the data and all, so you try to keep the data in the memory. So in the in-memory databases, you'll see that the data is not there. These are not like per persistent storages. So you'll just keep it from a processing perspective and all. So in-memory database systems are more useful where the reading writing you want to do or fast processing, real-time processing of analytics, and these kind of things are required. So you'll see that saying them. Then you also have the columnar compression solutions. So columnar databases, you'll see that where you want to store the data in the form of columns as compared to the volume data getting stored in the form of rows. So in a row-oriented databases, normally you'll see your standard SQL databases and all, which are more your transactions. So every new transaction comes in, it gets inserted as a row. So columnar storage databases are more useful where you want to fetch the data. Reading of the data is retrieving of the data is more important. So data gets stored in the form of columns, and because of which what happens is when you want to read the data, like for example, if you have a table which has the employee ID, employee name, last name, employee ID, first name, last name, you know, and you have the kind of, the whatever the score, and now you want to find out the select star from last name, then what happens is in a row-oriented databases, you will have to go to each row and then to each column and start fetching. Whereas if you store the data in a columnar databases, the data knows query knows that it has to fetch the data from the columns, and this columnar databases normally will store the data in the form of columns, and there is a key that is associated. So it just needs to identify the columns. It doesn't have to go for each rows and try to identify the data. So there is a very high performance benefit that columnar databases, and again the databases they use compressions for storing the databases data, underlying data. So primarily because of which the compression, you will see that normally the data is kind of stored and there is a pointer to the table of the states. So because of which compression is being also used. Flash memory, I think you all know, like we have flash memory, you have SSDs, these are primarily an attractive and alternative for your disk storage, so flash memory tries to combine the access speed of memory-based storage with the persistence disk-based storage mediums. So these are some of these types of data storage mediums. Again, each of them might be having some other categories. And you have SQL databases, NoSQL databases. In NoSQL, you have the columnar document databases, you have key value databases, you have the graph databases, you have vector databases. You have a vector database quite popular, quantum databases are for storing the quantum states of the devices, right? So different types of databases exist, a lot of them, and then there are certain databases will have a kind of other combination of these properties, like you might have been hearing the recent the different types of data lake houses and all, which has icebergs and Parquet files supports and all. So it's a kind of a combination of or a transition of the existing databases that are there by fine tuning some of the properties and getting a better storage, ways of storage the data within them. Then you have the different types of database environments that I was speaking about. So you have the different types of database environments that can have. Now, if you know that if you hear that each of them will have a specific purpose. You have the production environment, you have the pre-production environments, you have the development environments, you have the test environments, right? So test would be useful for your QA, quality assurance, integration testing, UAT, performance tuning, and all you want to use it. You have the sandbox environments normally for experiments perspective or small POCs and all. You normally have the sandbox environment. So again, which of these environments will be existing in an organization? It also depends on that maturity of the organization. Some of the, you just cannot say because there is a cost, there is a lot of effort, there is a person's identifications and all of these things is required. So maintenance is also important. So these kind of things also plays a very important role when you decide on the environments. Now, the database organization, normally in an organization, there you will see that what are different types of database organizational style that can exist. So there are three main. So now why these, databases have been required to be organized in this way. So you have the hierarchical, relational, non-relational kind of databases. These primarily you can see that they are not completely mutually exclusive from each other. Like for example, some database systems can start reading the data from both the relational and non-relational databases also. And hierarchical databases could be established using your relational databases, right? So that reason you can see that at a very high level, you have these databases. Now, these are also relational databases are also called as schema on write because they are mostly useful for large number of write operations or transactional operations. Non-relationals are also the schema on read, which are more useful for fetching a lot of data or reading a lot of data. And then you also have the hierarchical data, which is more like in the form of a hierarchical structures or tree schemas that you have. So hierarchical is the most oldest kind of a database model, which was being used in your early mainframes database systems and all, but it was a more of a rigid kind of a structure. So you'll see the data was initially organized in a more of a tree-like structure. So there was like a parent-child relationships. Each parent can have multiple children and each children might be having a single parent or one-to-many relationships as you have seen, right? So these directory trees were like an example of the hierarchies. And then you had the relational kind of databases, or we still have them, which was the relationship between the different entities, attributes was more important, right? So you'll see that it used the theory of relational algebra, set theories and all, where database elements, or the columns were related to each other. And then you had the tables or the entities, the relationships or the being established using entity relationships diagrams and all as part of DBNS concepts. And then you have for getting the data you have the DDL, DML statements, the SQL statements, SQL query language, the structured query language was being used for fetching out the data. Then within these relational databases also, you had multiple types, like you had the multidimensional kind of database, which was primarily useful in your data warehousing and business intelligence kind of things, where a lot of these databases were supporting larger data, cubes creations as well as storing multiple dimensions of data. Then you had the different temporal databases in database relational databases, which was more useful for time handling, or time traveling perspectives, like for example, I want to understand at a point in time history data or which is my current data, like the SCDs and all that if you want to establish, then primarily the decision time or the valid time, the transactions time. So the temporal databases were being useful to understand what is the current state of the data. And then the other states, you have the non-relational kind of databases that I was speaking about. So you have the which are more on the schema on read, where the data in the files could be read by multiple systems, multiple users, and different ways. So non-relational databases started becoming more relevant or more popular when big data as a concept started coming in. And my requirement was now not only to store my data, structured data, text data, but now I want to store images, audio files, video files, and all, and should have a better way of storing them at the same time retrieving this data. So non-relational databases are also called as NoSQL types of data. There is not only SQL databases. where the data structures, as you're going to see, could be in the form of a tree, a graph, a network, key value pair of the database, or columnar kind of databases. Documents could be there in the form of semi-structured kind of data, like MongoDBs and all. And I want to store them in the form of documents. So those kind of different types of databases you'll see. Like so, all of them has certain types of these data. Then you also have the spatial databases, which will be useful for storing the data in the geometric space. So normally now, if you want to store the data like the plots and those kind of things, you want to understand where the data, the measurements or the predict. I want to identify in the form of vector geometry and all. So those kind are useful like for your spatial databases. So these kind of different types of databases you might be hearing across, so that is just some of the ones that I thought of just speaking. And then as an extension of these databases, you will be hearing the data warehouses, the data lakes, the data lake houses, the delta lakes and all, which are primarily the specialized databases, that as an extension to these databases for the for setting up the central repositories for driving self-service, you would be using them. Then, in addition to that, you also have some of the other types of databases that you might be hearing, like geographical information systems or GIS, which will be useful for storing the geographical informations, right? Normally, it is useful for in the telecom industry for network management, or for example, in utility space and all, like gas lines and grid lines and all. These are useful. Then you also have the CAD or CAM, like computer assistant design and manufacturing applications. They might use certain kind of databases for storing their types of specific types of data. You have the directory services, like they are for storing the data in the form of directories. So those kind of things are associated. You will also see them. So these are non-relational, columnar, oriented, specialized databases that I was speaking about. You can just have a look at them. Now, there are different types of database properties or common database processes that you will be able to see. Like, so one of the very important property that you will see would be is called as archiving, where, you are trying to move the data immediately, from the accessible storage media and try to store it into a medium with a lower retrieval performance, right? So these archives you want to try to restore. You try to keep this archive at a point in time so that you want can restore them to the original system whenever there is any kind of a failure, system failure, if there is any requirement, then you want to have it. So normally this archiving is very useful because you firstly you try to keep an archive. You don't want to keep all my data in my live system because performance might be getting impacted. Similarly, it creates a kind of a backup that will help me to understand. And so that is some of the kind of things that you'll start seeing why archiving is required. Then second aspect that you'll see is the capacity and growth projection. So normally if you start with any of the projects, so normally the first thing that database administrators will understand is what is the size of the box or how much is the data capacity that you need, what is the kind of the growth projections that would be there, like how much data will keep on increasing on a daily, on a monthly basis, so that because I will have to plan for capacity planning, I will have to start adding more a number of servers or more number of storage mediums, right? That can keep on ensuring that the data is not getting lost, right? So I will keep on adding more capacity. So these kind of things you'll see that capacity and growth projections is one of the very important aspect that a database administrators will ask. Then you also have to change data capture. So change data capture is a process where you start identifying or detecting the changes that are happening and ensure that the data that is changing, only changing is being passed on to your downstream systems. Right? So CDC or change data capture is more like a log-based replication process rather than waiting for my end of the day to identify all the changes, which could be very huge. What I do is I can implement a CDC using my log-based replication methods so that I can start replicating my data changes to my target, right? So I'm not affecting my source, but at a point in time, I can start identifying only the data that is getting changed and can start pushing the changes. So CDC is very much useful to make your data in a more real-time or a near real-time kind of a scenario. rather than sending, rather than waiting for my entire changes to happen, So if there are minor changes or few changes that is happening, those deltas I can keep on pushing to my downstream systems. It's a very common, it's a very useful methods. I can start identifying, and there are two different methods to detect and collect my changes. One is the data versioning that I can do, which will try to evaluate the column that identify the rows that has been changed. And like, for example, based on the last date, timestamp, or the version numbers and all, or I can start reading my logs, right? So in my logs, the changes are being captured. So I can start pushing those changes, identifying and pushing. Then you also have my purging. So purging primarily is a process where what I try to do is I will try to, purge my data. I want to basically, normally I will not want to keep all my data residing in my primary storage or point in time, right? So just to reuse my entire space, and just to ensure that the performance is not getting, is not getting hampered. So what I do is I will archive my data and then I will try to purge my data. So I'm trying to completely remove my data from my storage medium. I will just keep it in case if I remove, I can redirect my user to my archive, and I can just complete after my removing my data, I can reuse that storage space for the new type of data. So normally you'll start seeing this kind of purging activity happens when you have a fixed server space allocated to the team, and you start seeing that the same use space has to be utilized. So any kind of unused files, old files and all keeps on requires to be purged very frequently, so that the same only the relevant files could be residing, and the old files and all could be purged. Or sometimes projects which have completed don't have anything, you can keep on purging all the unnecessary files, only keeping the relevant files. Then replication, data replication is the process where you're trying to replicate the data. You are keeping the data stored, the same data getting stored across my multiple storage devices. And we have seen that why it is important, because to manage the entire workload, so normally this is useful in case if there is a large number of requests that is coming in, more number of people, users are using the same data. So managing the workload across the only a single database would be very difficult. So what we do is during my peak usage times, during my peak cycles and all, we try to these kind of replication starts helping. So we have a replication that could be also of two types. You have something called as the active replications. So we have the active replication and we have the passive replications. Now, active replication is where you are trying to recreating the story and storing the same data at every replica from the other replicas. That is part of your active replication. And you have my passive replication, where what you're doing is you're recreating and storing the data on the single primary replica only. And then what you're doing is from the primary replica, you're trying to transform this data and then whatever the final resultant state it is to the secondary replicas that you have. This replication will have two types of scaling. These are two dimensions. You can do a more of a horizontal data scaling, by creating more data replicas horizontally, or you can have a vertical data scaling. So you can see that the scaling can happen in a vertical fashion. Then you also have something called as multi-master replications also possible, where the updates can be submitted to the database nodes, and then that could start rippling to the other servers also possible. Now, there are two main primary replication patterns that are available. So one is called as mirroring and one is also called as log shipping. So what is mirroring? So mirroring primarily what happens is the updates that are there to my primary databases, they are replicated immediately to the secondary databases, right? So that is primarily you'll see associated as part of my the entire application. In log shipping, what happens, the secondary server that you will have, right? It will try to receive, it will try to apply the copy of my primary database transaction logs at a specific regular intervals. So the choice of the replication methods, it also depends which kind of a replication pattern you want to use. It depends on how critical the data is, and then the failover kind of conditions. So mirroring normally, since the updates are from to the primary databases are replicated immediately, is much costly. It will be more expensive because there is a two-phase commit process. And log shipping, since the secondary server is receiving and applying the copy of the primary database at a regular interval, so you'll see that log shipping will be, little less expensive. So mirroring is effective for one secondary server, whereas log shipping could be useful to update multiple additional secondary servers. Then you also have resiliency and recovery. So as you have understand, right, like resiliency in the database is one of the very important aspect, which speaks about the how tolerant the database is to any kind of an error conditions or any kind of a failure. So like if the system is able to tolerate uh, high level of processing errors and still able to function as expected, then it is very highly resilient, right? Whereas if the application is able to is crashing, you know, upon my first unexpected condition, then the system is not very much resilient, right? So that resiliency is very much important. Now, while in case if the system is not resilient, right, I should always even, and no system could be 100% resilient, So what are the other options that we have? So what we should have is we have some kind of a recovery, right? So the recovery types, three main recovery types are associated that will help you to identify the how quickly that recovery can happen. So to make the system more resilient. So one is an immediate recovery, you have a critical recovery, and you have the non-critical recovery. Now, immediate recovery, as you can see, you know, is by for some of these issues, through my design itself. Like for example, you can start predicting and automatically resolving some of my issues due to a failure and all. You'll start giving us some kind of an notifications. This is primarily an immediate recovery. Critical recovery is where as quickly as possible we should be able to do it so that the entire business operations is not getting shut down. So that is the critical recovery. And then you have the non-critical recovery. So non-critical recovery is where the restoration could be delayed to some extent. So it is not very critical. So as compared to your critical, so you have your SLAs defined accordingly based on the criticality of it. So extremely critical, so they will have to have a kind of replication pattern so that it is happening immediately without much time lapse. Whereas, non-critical recovery could have some time available for that. Then retention is also one of the very key concept, a very important aspect that you define, and in your policies in as part of your database administrators and your data storage requirements also, retention plays a very important role. So what is data retention? So data retention speaks about how long my data could be kept available, how long my data could be kept available and in my database, and what are my retention requirements so that I can need to start planning on my capacity planning as well. And so database retention also plays a very important with respect to data security, right? So some of my data requirements, like for example, my customer informations and all, I want to keep it retained for some specific time frames. Some organizations define some policies. Some of them are aligned with some of my regulators requirements, regulations requirements. So accordingly, there are time frames of like 5 years, 10 years. Sometimes organizations keep that retention things. After that, sometimes I might have to purge my data. I might non-critical data I might have to purge. I will have to keep in. So it goes into those level of detailing, retention. It's not that same policy can get applied to everything. You will have to start having these granular discussions to understand what needs to be retained for how long. Then sharding is a process where what you're trying to do is you have horizontal sharding and all vertical sharding, right? So you is a process where this small chunk of the database you're trying to isolate, to each of the others, and what you are doing is these shards primarily will help you in the replication, So this kind of replication and sharding is useful when you want to scale up your databases, horizontally, you want to add more a number of clusters and, you want to scale it up or to scale it or, want to scale it very easily. So these kind of things you will be able to see as part of my sharding. Now, what are the different types of activities that are associated? So one is the manage the database technology. Second is to, managing the different types of databases. And then you also have different types of tools and techniques that would be useful. So we'll just spend some time quickly just to understand some of these methods, right? So, first thing, starting with managing the database technology. So, these will follow the same principles and standards that will be useful for managing any technology. Now, the reference, you can use some of my reference standards like an ITIL, the Information Technology Infrastructure Library, as one of the model. So they have mentioned some of my principles that will be applied for managing my data technology. Right. So, for example, you understand what is my database technology characteristics. You try to evaluate what is my database technology, underlying database technology, their product architecture, volume, velocity, application profiles, specific functionalities, and all. You try to understand them. Then some of my factors not related to the technology should also be evaluated, like organizational appetite for risk, then supply of availability of professionals, cost of ownerships, licensing, maintenance, vendor reputation, support policy, customer references, all of it. Then how you start monitoring and managing the database technology. So that is also very much important. So how you define your L1, L2 supports, technical supports, what are the people, what are my vendors that you might have to incorporate, what are the role of my DBAs is, so those kind of things is where you try to manage and monitor the database technology. And then for managing the databases, so managing the databases will have certain some subtypes. Like for example, you start with understanding your requirements. So within that, you define your storage requirements, you identify what are the usage patterns which are there, you define what is your access requirements, how do you start planning for your business continuity. So in that, what you try to define is what are the different types of backups that you want to start doing. Uh, what are the kind of what will happen what kind of different types of losses that can happen with respect to the physical database server, there is storage spaces, a lot of databases, the corruptions, and the file systems, the loss of transaction log files, all of it is something. Then can you start making backups, regular backups and start recovering the data as well. That's very much important. Then how you start developing the database instances, right? So the normally the DBAs are responsible for creation of these database instances. So there are different types of related activities which will be there. Like you start installing and updating the DBMS softwares, start maintaining multiple of these environment installations across the different DBMS versions, install and administer different types of related data technologies. Then how you start managing your physical storage environments across the different types of environments that you have. You manage the physical storage environments across the different types of environments that you have. Then you start to do the configuration identification process, the configuration change control, the status accounting, or configuration audits. You start doing that. Then you manage the database access controls, right? So across your database access controls, you have certain called of control environments that you might have, the physical security monitoring aspects that you will have to take care, and the controls that you need to build in. Then you start creating your storage containers, you start implementing your physical data models, you start loading the data into the databases, you start managing your data replication. So all these are part of your database when you start your development activities. Then the next thing is what are the different types of SLAs? You define certain kind of performance service level agreements, right? So across the service level agreements, you can have the system performance, system availability, system recovery, or database performance, database availability identified, and you define who are the people who would be responsible, accountable, controlled, and who should be informed as part of it. And then you manage your database availability. So database availability includes your manageability, recoverability, reliability, serviceability. What are the things that you might have to look into to prevent the databases from, getting losing the data? So what are the planned outages, unplanned outages, application problems that could be there, data problems, human errors that could be coming in, and what are the responsibilities of the DBAs for each of these? Then how you start managing your database executions, you maintain the database performance level SLAs, then the transaction performance and the branch performances, batch performances that you start looking into. Then what are the issue remediations that you will be doing? What kind of issue remediations you will be doing, right from memory allocation, locking, blocking perspective? What are the inaccurate database statistics or the statistics that you would be looking in. Sometimes you might have to look into the poor coding techniques and start giving them feedback. Try to understand what kind of joint queries have been there. Sometimes people was just applying full outer join and some kind of standard joins across, but it is not very much efficient in that thing. So can you start applying indexing? Can you start looking at the application activities and monitoring? So these kind of things you will start seeing as part of it. And then how do you maintain some of the alternate environments like development environments, test environments, diverse environments that we have seen? Now, one of the very important aspect is to manage the test data. Now, test data sets is very much important because software testing will be important, right? So that speaks about, the entire process that is associated with your test data management. Then data migration plays a very important role because you will try to transfer the data between the different storage mediums across different formats or the different systems. So data migration is a separate area in itself, where you need to the data migration strategy, migration approach and all. You will try to move the data frequently. So you have data migration strategy and steps. Then post migration, validation, consolidation, reconciliation, all plays a very. So it's a separate area in itself as part of your data migration. So normally you should have a data migration strategy that defines a lot of these activities. Then what are the different types of tools that you can use? So you can use combination of different types of tools, like for example, data modeling tools that would be useful for generation of the DDL statements or reverse engineering perspective or standard naming checks, spelling checks and all metadata components and all. You can use that. You have the database modeling tools that can use monitoring the key metrics, capacity, availability, cache performance and all. Then you have the database management tools for managing, right? So the DBAs can manage these you using a single tool, all the different types of databases. So right from configuration, installing, applying the patches, upgrades and all, backupping and restoring, database cloning and all, the database management tools would be useful. Then you have the service developer support tools that would be useful for developments. So these could be useful. Then what kind of techniques that could be used? One is you start testing in your lower environments first rather than applying into your production at a point. Normally you start with in your development or sandbox in your test, and then you move into production. You apply some of the physical naming standards like an ISO 11179, which speaks about the meta registries, which addresses the semantics of the data, the presentation of the data, the registration of descriptions of the data that you start looking into. So the naming and identification principles plays a very important role. Then what is the kind of the script usage that you would start using, So what kind of script changes are required or, these kind of things you start looking into the script usage, any kind of changes that are coming in. So there should be a kind of a defined process, so code migrations or code deployments and all those kind of things. So these kind of things also play a very important role. From an implementation guidelines perspective, first you do a readiness assessment and a risk assessment. So in this, there are certain kind of key aspects that you look into. First is the data loss. So data that will be getting lost, so you define what are the kind of risk that is associated, what are the SLAs that is defined across them. You document them, would you define the processes, and then you also sometimes, in case if the data is being lost, like sometimes the data is being accessed in the dark web and all. So can we have the proper insurances and risk mitigation plans in place? Then technology readiness perspective, can we start looking into the upcoming newer technologies, NoSQL, big data, data lakes, delta lakes, icebergs and all, which will be useful, because there are continuous development changes that is coming in, that is there. From an organization perspective, what kind of organizational changes that I want to have, right? So one of the very important problem that you see is after on one side the technology teams wants to get all of these things, but the business support is not there. So proactively communicating is one of the very important aspect, making people understanding the differences and the benefits. It's very much important. Keep your management aligned right from the beginning is very much important. Then also start measuring what is the return of investments, like for example having the previous values, the previous metrics, and showing the benefits with respect to what kind of, like for example, executions, query execution speeds have improved, and those kind of things. Those smaller benefits, when you start showing, also people start realizing, yes, there has been certain kind of a benefit that we have got as part of my investments. Stay business focus. Try to see that everything that you are trying to do has some kind of a business kind of a benefit, because then that is where people will start driving and pushing and supporting you. Try to make people aware, try to help them understand it. Sometimes you might be very much aware of a lot of these benefits, but others might not be. So try to help others, try to get that level of understanding and all. And also, a lot of this you will see that you'll start learning along the path, right? So learn continually. Don't give up in case if it has failed. Try to take them as a learning thing and start going forward. So that's very much important. These are some of the metrics that you can see. So like, for example, from a data storage metrics perspective, the count of databases, aggregated transaction statistics, capacity metrics, number of storage use, containers and all. So these are sometimes being used by the database administrators and all. Similarly, from the performance perspective, what is the transaction query frequency, quantity, query performance, API surface performance? From an operational metrics perspective, what are the aggregated statics, backup size, data quality measurements, availability, service metrics? Might be there, issue submission, resolution, escalation counts, all of it might be there. From an information asset tracking perspective, you require to have the total cost of ownership for all the technology, right? So on one side, you have the licensing requirements, which is plays a very important role. On the regulatory requirements that would be required. At the same time, as I was mentioning, the total cost of ownership that would be there. So regulating and identifying and tracking these information assets plays a very important role. Then you also have the data audits and data validation. So data audit is primarily where we're evaluating the database data sets based on some defined criteria. So you do data audits so that you want to investigate certain specific concerns about a data set and try to determine what was the data, is it meeting the compliance requirements and some of the internal policies. So that kind of a data audit approach is very much important. So there are certain kind of comprehensive checklists you might have to look into, required deliverables you might have to look into. What are the quality control criteria that is there? So that's a very important aspect. And if you see, data validation is this process where you're trying to evaluate the stored data. You have your established acceptance criteria. You define the quality, the usability. So there are different, these data quality audits have been done by you can start help develop the reviewed approach where you start there are certain kind of supports that might be required right from performing the preliminary data screening review, developing the data monitoring methods. You start applying statistical techniques as well to optimize and analyze the data. You start doing sampling and analysis as well, start reviewing the data, start providing support for data discovery. At the same time, you start acting as an SMEs, subject matter experts for any of the questions related to the database administrations. So those kind of things you'll start looking into, which would be so this is it primarily on the data storage and operations, a topic which has a very good, has a very high relevancy in as part of the overall data architecture and the overall data organization initiatives. And there are multiple parts to it. The only thing is, as you see, uh, everything cannot be done. It's not a one single person's role, only the DBA. There are multiple people who would be involved as part of the entire activity. So that's something that you will start seeing that is playing that is also plays a very critical role as part of this. So I will stop here and I will see if